What's going on, guys? Welcome to the steady state summary. In this video, we're going to be covering some different biomolecule attributes that are useful for purification, especially the isoelectric point, as well as a small review of some of the different techniques we have covered in class up to this point. For starters, what exactly is a pI value? The isoelectric point for a biomolecule is a pH where the net charge on the biomolecule is zero. This, however, does not mean that the biomolecule is without any charge at all, as different groups could simply have charges that even out to zero. Knowing the pI of a certain biomolecule will allow you to determine what method may be best for separation, using different techniques such as ion exchange chromatography. Not to mention, these methods of separation are all based on weak interactions, as is much of the information in the course thus far. This method, shown here, is a good way of going about determining the pI for a certain biomolecule. Create a small table on your paper with all the amino acids that contain side chains that have pKa's, as well as the C terminus and N terminus if it's an amino acid chain. List the groups in order from lowest pKa, or the most easily deprotonated, to the highest pKa, or to the least easily protonated group. Include columns for what the charge would be in their protonated and deprotonated form. For example, for the carboxylic acid group, its acid form has a charge of 0, while its base form is negatively charged. After the chart is complete, you have yourself an easy setup to determine the pI. At a pH somewhere in the range of 2 and 8, the cysteine has a net charge of 0. Anything above this arrow indicated will be in its base form, since the pH is greater than the pKa's, while the groups below the arrow will be in their acid form, since the pH is less than their pKa's. To estimate the pI, simply divide the two pKa's that the arrow falls along. For cysteine, this would result in an isoelectric point somewhere around 5. Although this is not a foolproof method, it can give you a rough estimate of the pI of a chain of amino acids, and estimating the pI will be good enough on exam day. On this chart is the completed biomolecule methods chart from one of the packets given to you in class. All I can say for this chart is to know it, study it, review it, quiz yourself, and more. Knowing the exact ways these different methods view levels of structure and dynamics is beyond the scope of this class. However, knowing the basics of what they can and can't do is essential for exam day. If you guys have any questions about the material presented in these videos, please let me, Dr. Bernstein, or any of the other TAs know. Stay easy.